everybody, my name is Josh. I was a computer science examiner for multiple exam boards, head of computer science in UK-based schools, and now I run a tutoring business. And I've been trying to create as many lessons as possible that are going to be helping you out for your upcoming exams. And today's lesson is all to do with object-oriented programming. Now, I've tried to condense as much information as possible into this lesson. And essentially what I'm going to do is, I'd strongly recommend is making a flashcard per topic that I'm going to go over. The ways that we can drive improvement, even if you've got a very short time until your exams, is the keywords, obviously. I'm also attached the code for specific topics. So how to, for example, override something or use polymorphism. If you can just remember what I've put in there and fit it to the scenario, you'll be able to get some of the marks in the coding ones. So there's two parts to this. Can you remember the definitions? And can you remember the coding associated with it? So first of all, what is a class? OOP is this idea of we use classes to create what's called objects. And the classes are our blueprints for this. This is what is going to define our the properties, and also going to define our actions of our object. So this is what's shown as in the methods, which I'm going to talk more about in a second. Here underneath, what I've done is I've defined the class car, and what I've done is I've put a constructor under there. The constructor is what I use to initialize, which that is why you could technically call it something else, but it's just common practice that you would use init with the little slashes next to it. Underscores is the correct term. We put self next to it, so self, comma, and then we've got the different attributes there. So we've got registration and make, so the things that we need. So what you would always do is you'd always put self, you would put a comma, and then whatever the question is asking you to do, you've got you'd put the attributes. In this case, they wanted to make a registration and make of the car. We've also got, we're going to be setting certain attributes that are, so we've got mileage, and then we've got date of inspections, which that will help later on when we're talking about that question. But this is the general basis of how you create a blueprint for an object. So with the attributes and methods, these are the characteristics that we want to associate with our object that we're going to be creating. So in this case, with a car, the attributes are the properties that we want to have. So this would be like mileage. With this one, it's talking about having a date of inspection. It's also talking about, we've got a make, registration. And then how that differs to the methods are these are the behaviors we want to have. As you can see, we've got the getters and the setters, which we'll talk about more in a second because they're very, very important when we're trying to assign values, because obviously every car is going to be different. These are some of the behaviors that we want to have, and I'm going to show you how they work. But generally, what I would say is that the attributes are the properties that we want our objects to have. So this might be, the color of the dog, the mileage of the car, just any kind of attribute we want this object to have. The methods are the behaviors that we want. So, this might be that we might want the dog to bark, and the methods have a impact on the attributes. So we'll have a look at that a little bit later on, but these are just the general basics of some of the keywords and what they mean. One of the things that's going to be talked about is whether something is public and private. Generally, attributes are normally declared as private. So things like mileage, date of inspection, that means that that someone else can't come in and edit those. A method is normally seen as public. So these are the behaviors that we want to have. And the main concept from this is that you don't want the attributes to be changed unless a method is activated. So if I feed an object, one of the ones which I always talk about with my students is how a Tamagotchi, which is sort of an old little game sort of system, and what you can do is there's certain behaviors that you can apply to it. So if you feed it, what that will do is that will increase the amount of time that you have to. So its hunger decreases. So the method on that of feeding it increases so it decreases the hunger. So that means that you have a longer time before that you have to feed it again. And that is a perfect example of OOP, where your Tamagotchi will have some certain attributes which you have a certain amount of time to do certain activities to it, stop it from being bored, stop it from being hungry, and it's applying those methods on there is the thing which increases the amount of time that you have to do between those. And OOP works on this basis that the methods are the things which change the attributes. Encapsulation and data hiding is this idea that the attributes and methods they hide the details of implementation from the user. And it will simply ask you in the exam paper, what is encapsulation? And it's this idea that the attributes and methods, so keywords that you're going to use, attributes and methods are hidden. The details are hidden from how the implementation is from the user. Now, if you've actually coded it, you will understand how it works. But if we take an example which you've been using quite a lot, like if you apply random, it's unlikely that you actually know how the fully ins and outs of how random works. But what random does is it will it will give us a random number based on whatever it is that we're trying to do. And we don't need to know how that works. The data is hidden from us. It's encapsulated. And that's really, really good programming, is when we can use something, but we don't have to fully understand the ins and outs of how all of these different functions, methods work. And that's what encapsulation is. One of the common questions in terms of programming is how we create an object. So I know that technically this isn't going to be absolutely correct, but what I've got this idea of is defining and calling it, and as you can see I've put the little quotation marks around it. I'm trying to get you to understand that the two of these work in combination with each other. Okay, so I think the closest thing that I can give you an example of is that you have to define your class, so you have to define the blueprint, and then what you can do is you can call it. I know technically that's not the correct thing, but I want you to understand. My job as a teacher is to help you understand these things, and this seems to work quite well when I've been teaching my students before. Is we have the defining part of it, similar to with a function. When we define the function, if we then don't call it later on, it's not going to do anything. And then what we can do is then we create an object. And how I do this is I almost create a variable. And then what I can do is I can activate that class and pass, as you can see, I pass the registration. I know that's a bit of a strange registration, ABC. And then I just say the make in there as well. As you can see, self, we don't have to put anything in there for that one, but ABC goes into the position of registration. This goes into there, and then you have created an object by using the constructor, and then you've created an object, and those two work in tandem together. If it simply just asks, can you write a statement to create an object? All you need to do is you need to just put something along those lines. But I want you to understand that these two work together. If without this one, you cannot create an object. So that is a tricky concept, which I see a lot of students not understanding. So as I said, technically, is it defining and calling it? No. But I want you to know that they are paired with each other, that without this, you cannot have this. Instantiation is the idea of creating an object. So if it talks about instantiation, what you're doing is you're creating an object. So that's just a fancy word for saying is creating an object from it. So that's the key word there, instantiation. How to use the dot notation. So again, I just thought I'd show you another example. So we've got the class of dog, we've got the method bark, and what we've also got our constructor there. So just showing you a different example here. So I've created an object of dog, I've given its name, and I've given it its color. That is now an object which is created. And if I wanted to use a method with it, what I can do is I can attach, well, that should be a 1 there. Sorry, I must have been doing one of the other ones. But yeah, imagine that's my dog 1 dot, and then we just use the method that is associated with it. So in this case, it's going to be bark. And then what we do is we can put how many times we want it to say woof. So it's going to go, so I've put in 3. So that will say that 3 times in there. And that is going to, and that is how that you start getting the fundamentals in. And it's this dot notation. You put dot, similarly to, when we've used random and some of the other, some of those other functions in the past, you use a dot notation. It's, dot upper. It's using a similar method to that. So that's generally how we use the dot notation in there, and that's the basis of it. And again, using that method, I know technically it's not doing that, but I just want you to know that this, without this, you cannot get this. Okay. Common question is talking about what is called the setters and getters. Due to this thing called data hiding, which we've already talked about, we cannot directly access and change attributes of an object. So say we've got all of these cars. Let's say that what I want to do is I want to check a specific car and I want to see what its registration is. What you do is you can define what are called getter methods. Getter methods will simply just display the information for a specific car. So for whichever car that I have created, my car, what that's going to do is that's going to go and find out its registration and display it. How I define the getter method is like this. I put def and then I give it a name, something similar to get registration and then self. Earlier on, what I will have done is I would have defined an object which is specific to this one. And then when I activate it using my car and then using the dot notation of dot get registration, that will then display it. So whatever that registration may have been. To set or change the attributes. So it's again getting that idea, and this is I think I see a lot of students really not understanding this because they're like, why can't I just go in and change it? So once the object's created, we have to use what's called a setter to be able to actually set the attributes to something else. To define a setter, we call it something like set inspection data in that case. Self, so we make sure that we put self, comma, mileage, so the thing that we want, the actual attributes that we want to change, and date. And then what we do is we put self dot, this is just the format. You could technically put just self dot mileage, but it's just common practice. It's a little bit like when you use like for I in range. You don't have to put I, but it's just what everyone puts in there. And we get set mileage to whatever the person has set in there. Date of inspection, we set it to date. And as you can see in this position here, I've set it to 1,234 miles. So that goes into that position now. And then date goes into there. And it's this idea that this works in tandem with this. So this is how that you can check your values if you need to check them for whatever reason. You need to be like, oh, I can't remember what the mileage is on this car. We just go my car dot get mileage, and that will produce as whatever that particular object's mileage is. If we need to set and change the attributes, that's what we're going to do. Inheritance is another one of those keywords. So what happens there is it's where we've got what's called a superclass, and then you will have subclasses underneath that. you will have maybe the animal superclass, and then you'll have the specific animal, dog, underneath it. And that's going to inherit some of the attributes and methods of the superclass, and then we'll have some of its own methods because there's going to be some differentiating factors from it. So it's this idea that it inherits all attributes from the superclass. As you can see here, we have got for animal, fish is going to inherit stuff from animal, and duck is going to inherit stuff from animal. How do we actually do this though? So if they ask you to show this in and code this, you're going to have your superclass. You maybe don't actually need to code this, but I just wanted you to see those together. So you've got the animal superclass, and it's got the different methods, and you've got the constructor and the different things that you need. But how do I use inheritance? So what I do is, if I'm going to create a blueprint, a class, a subclass of animal, I just put fish, and then I put the superclass in the brackets there to tell it that I need you to inherit all of the features from this one up here. I then can change some of the methods to whatever it is that I want. So if I've got some additional methods, which is set max size, and that is how I do it. So the key thing is if the only thing that you can remember, nice simple flashcard, is to inherit things from this, what I have to do is I just have to put the name of the subclass, and then I'm going to get the super, and I just write the superclass in the brackets after it. Now, one of the things with inheritance is we can use things called polymorphism. Now, polymorphism is this idea of the class hierarchy. So different methods can behave differently in each class. And this can actually be achieved through something called overriding. So that might be a situation where I actually want it to, even though it's inherited a lot of different methods and attributes, I still want them to behave differently. So let's have a look at how they're key words that are used. Polymorphism is how we get the methods to behave differently. So let's have a look at that. Let's say that I've got the animal parent class where I've got some of the features in there. So I've got feed, I've got my constructor, and let's say that I've got fish here. So what I've done is I've actually said that I want feed to behave differently. Just write it as usual. And then what I'm going to do is I just overwrite it. So I'm just telling it, I want you to behave in this way. So instead of increasing size by 1, I want you to increase size by 2. And I haven't put anything to do with fed there or anything. Okay. Oh, sorry, I have there. Sorry, I have put that under there. Okay. The main difference is that I've changed the 1 into the 2. And then I can put in whether, here they wanted to do some different things to do with max size. But I just wanted to show you this example here, which is essentially saying that this is now behaving differently because each object that we create is going to be slightly different from one another. So instead of it increasing by 1, I've overridden it, and it's now going to behave, and it's going to go up by 2. This is just another little example here, which is just that we're overriding some attributes. So let's say that we've got a pet tiger. Bit of a strange example there, but let's just say that the attributes I've just said that it may have some preset ones for bored, intelligence, and hunger. I use say that I want you to inherit all of the things from pet, but I'm going to change these attributes. So bored, intelligence, and hunger is going to equal those things. This one here, this is how that we override the constructor. So how we actually create the objects. So as you can see here, the way that I do this is that I use the dot notation, and I can just change the values in here to what it is that I want it to be. So for example here, the way that they want to change it is that we're going to be setting max size on there to 2. Just quickly showing you a class diagram in case you, with inheritance, so sometimes they get you to draw these. So, for example, animal is going to have fish and duck coming off it. And the things that we've got in here, so little tips. So it's just like a fill in the blank, or they could just get you to draw one of these. So that the parent class is the one that is going to go up here, the superclass. Then we've got the subclasses underneath here. Now there's 3 different things that you need to know, which is public, private, and protected. My little tips for being able to answer these questions. Protected is generally just going to be the ones, is going to be the attributes, I should say. So attributes in the top box and methods in the bottom box. So if it talks about behaviors, they go in the bottom box, attributes in the top ones. And as you can see, we don't have to write all of those in there. So like state and size for every single one of them, because unless we're going to be overriding them, which in this case is, max size is going to differ from the size one, because is going to inherit these ones from animal. Now protected, what you're going to do is they are going to be the attributes from the superclass. Generally, if you can remember that all methods are generally declared as public, so when in doubt, just go with those. So you put a little plus next to those, and you just put the data type next to them. And then what you're going to do is then for any of the other attributes that may be in the subclasses, duck doesn't have any, but can you see that one's going to be private? So it's just, if you go with that rule, that the protected ones have a hashtag next to them, which that's going to be the superclass, and they're going to be the attributes associated with them. Underneath that, you have got the you've got the methods, which they are going to have a plus next to them. So the behaviors. And then finally, what you've got is you've got the attributes from the subclasses, which they're going to have a minus next to them. If it just asks you general advantages of OOP, extensive planning phase for better designs, which is going to speed up development time. Generally, just make sure you link it to how development time is going to be faster. Also, that you're going to say that existing objects programs can use existing objects without the need to know how they're implemented, which this speeds up development time. Less likely to have errors in them because they're going to be more rigorously tested. Good framework. I would say maybe get 3 of these down. 4 just to be safe. Okay. As I said, with all of this, I really hope exams go well, people, and I hope that was useful for you. I tried to get as much information in there as possible for you from general questions that I see. Pair it up, definitions, question with the coding as well, just to give you a rough idea of what you need to do. The simplest one is just going to be knowing the definitions to all of those key terms in there. Best of luck, people. I'll try and get some more content out for the rest of the week. I hope the exams go well.